Hello, welcome back to the course on data science. I'm myself Jayesh and I'm your course instructor for this course. Today we will be talking about the most crucial part of machine learning, that is data preprocessing. So I request you all to watch this video up to the end, and if you have any query then please feel free to ask me in the comment section. I'm really excited to have you here and I can't wait to see you inside the course section. Welcome to part 1, data preprocessing. We will start by learning and doing data preprocessing in Python. I'm super excited to begin with you the machine learning journey. So, as you can see, I have opened Google Drive in my computer. I have made special folder directories. There you can see the machine learning course is split into 10 parts. And today we are going to talk about data preprocessing. This is the first very important step of this journey, because indeed anytime you build a machine learning model you always have a data preprocessing phase to work on. You have to pre-process the data in the right way so that the machine learning model that you are going to build can be trained the right way on the data. This will not be the most exciting step, but I will make sure to do this very efficiently so that we can rapidly proceed to branches of machine learning where we are going to build some models. One more important thing to note, the drive link of the same folder has been provided to you in the description. You will find the code as well as the dataset there. Without spending more time, let's go inside the practical section. Okay, and now we are going to tackle very quickly the very first step of this toolkit, which is libraries. I will tell you here how to import these libraries anytime when we start building new machine learning model. There we go. This is very simple. Now in this code cell, I am going to import three libraries. First is NumPy, second is Pandas, and third one is Matplotlib. So NumPy library will allow us to work with the arrays, because your future machine learning models will expect some arrays as the inputs. Then we will import pandas. This library not only import the dataset but also creates the matrix of features and dependent variable vector. And finally we will import matplotlib. This library will allow us to draw some beautiful charts. Okay, so let's get started. Here I'm clicking on the plus code button. So this will create the code cell in this Google Colab. Now I'm going to import the main three libraries. The first is NumPy, second is Pandas, and third is Matplotlib. Okay. NumPy as second is import matplotlib dot pyplot as okay, fine. So here I have imported all the libraries. So here I have used this command import. So this command is used to call the libraries, especially in Python. It is used to call the Python libraries. And here I have wrote like import numpy as np. Here np is just a shortcut which is used to call the numpy library. Like in this second code, here it is written plt. So plt is used to call pyplot module from the matplotlib library. Okay, so here we are going to execute this cell. So I will press the shift enter to execute it. Okay, done. Coming on the next step, here we have to import the dataset. Let me quickly show you the dataset on which we will be going to build the machine learning model. Here is the file data.csv. Let me open it for you. Here you can see there are 4 columns. There is country column, age column, salary and purchased. Well, now let's import the data.csv file in the notebook. So first of all, I will click on the file selector and then extract the data from my local directory. Done. .read CSV is the function to read the CSV files. If you want to see the first 5 rows of dataset, you can write df.head. You can see now the first 5 rows from the dataset. Now I will extract 2 entities from this dataset, say x and y, where x refers to independent variable and y represent dependent variable. So can you tell me by looking into this dataset which columns are independent variable and which one is dependent? Alright, I'm pretty sure you got it. Here's the dependent variable. Extract the features from the dataset, and y variable is the output we got using those feature values. So in this dataset, country column, age column and salary are the independent variable and purchased is the dependent variable. Let's import x and y variable from the dataset in the notebook. Here I am using ilog function to get specific rows and column from the dataset. In the case of x variable, in bracket I put this indexing empty. It means it will extract all the rows from data frame. But in other side I put the -1. Here it represents that we will be taking all the columns except last column. It excludes the upper bound. If you don't know this concept, please go through slicing in Python. In case of y variable, I put only one column. It means I put only column. It means I have taken all the rows, and at the other side I put -1 as index. It shows that I am taking only last column of the dataset. Dot values is the method which returns all the values belonging to the specific rows and columns of dataset. Now we will print those variables. Here you will observe that we get array of x with 2 dimension of shape 11 by 3 and y is 1D array with 11 elements. Next step is handling the missing data. In the dataset you can see that in the 5th row and 3rd column the value is missing. In another case, row number 7 and column number 2, there is another missing value. If we ignore these values and if we run the dataset to build the model, we would definitely get the huge error. So one of the strategies to handle the missing value is removing that specific row or replacing the missing values with the mean of all the values of respective columns. Let's do that. Here I have used scikit-learn library. It is most important and powerful machine learning library. It consists of lots and lots of complex machine learning algorithms. Here we have imported the class simple imputer using impute module. Then I created the object imputer using class imputer. I have mentioned 2 attributes, one missing value and other strategy. I put missing values equals to np.nan and strategy equals to mean. It means it will replace all the missing values using mean of the values of respective columns. Then I applied .fit transform method on imputer object so that I can get the new values of x with replacing the all missing values. Okay, now let's print x and see the result. Now we can observe that missing values here are replaced by those decimal values.
The next step is encoding the categorical data. So first of all, let me explain you what is the categorical data. So in this data set, you can see here there are four columns, among which country and purchased has theoretical data and age and salary has numerical data. If we are going to fit the same model as it is in the machine, then machine will not understand what the country column trying to say and purchase column. So first of all, we have to encode this categorical data into numerical data. So let's do this. So here I am going to import the two classes. One is one-hot encoder and second is column transformer. Okay, so here I have imported both of the classes. So here one hot encoder class is just an encoder which we will apply to encode this categorical data, and column transformer is a way through which we can apply this encoder, one hot encoder, on the columns. Okay, so I will create here the object CT of class column transformer. Fine. So you can see here there are the attribute of this class. So first of all, I am going to provide the transformers attribute. Here I am providing the list of a tuple. So encoder, then I will provide the name of the encoder. So name of the encoder which we are going to apply is one hot encoder. Then I will write here the index of the column. So index, so you can see here in the data set the index number of this column is 0, and I have to apply the transformation only on this column, not on age and salary. Okay, so here I put only 0. Now I will pass another attribute, that is reminder. Pass through. So what this reminder does, this actually keeps the another columns untouched where we don't want to apply the transformation. Like here I have provided only index number 0. So what reminder pass through will do, it will just apply the transformer here, and it will put those columns as it is, and it will pass those columns in the new result without touching it. Okay, so let's apply the fit transform method on the x variable. Fit transform. Okay, fine. Let's execute this cell. Press the shift and enter. Sorry, here is the mistake. Let's execute again. Okay, fine. So we successfully executed this code cell. Now we are going to see X, how it is look like. So print X. Okay, here you can observe some values like 1 0 0 0 1 0 instead of those categorical data like countries column. So let's check what is the difference in the X variable which we got and the dataset country column. Here you can see France first value in the column, then second is Spain, and third is Germany, and then it keeps repeating like Spain, here is Spain, here is the Germany. So you can observe here that for the value of France, here you got 100. For Spain, it is 001, and in case of Germany, it is 010. So for every different country column we got different values. So we finally encode this categorical data into the numerical one. Okay, now let's coming on the purchased column. This is the dependent variable. So here we can see that there are only two types of values like no, yes, no, yes. So in this case we are not going to apply one hot encoder, because one hot encoder mostly we use this where there are more than three values, but here there are only two different values. So here we are going to apply label encoder class. So let's do it. I'm going to import label encoder class. So from scikit-learn dot preprocessing import label encoder. Okay, fine. So I'm going to create label encoder class of that label le object of the label encoder class. So I will just put it as it is. I'm not going to provide any attributes. Let's just keep those attributes as default. So now I'm going to apply the fit transform method on the y variable. So le.fit transform y. So let's execute this code cell and see the result. Okay, fine. So let's print y variable. Here you can see the values as 0 1 0 0 1 0 0. You can see in the dataset here first is no. So the value given by the model for the no value is 0. For yes it is 1. So it is keep repeating randomly, it is keep repeating like no no. So here you can see 0 0. So these values can be understood by the machine learning model. So in this way, we encode the dependent variables by using label encoder class. Now, the next step is splitting the dataset. This step is most important in the machine learning. Let me explain you what is meant by splitting the dataset. So, in this dataset, we are going to split this data into two sets. One is training and second is test set. Then I am going to fit the training set into the ML model so that model can learn and evaluate the relation between dependent variable and independent variable. Then we will use the test set to predict the output values. In this case, the output values are purchased. Let's do it. So I am going to import train test split function from sklearn library and model selection module. Okay. Now here I will be importing, I will be extracting training set, xtrain set, xtest set, ytrain set, and ytest. Calling the function train test split. Then we will be passing the attributes. First is x, second y, then the another attribute is test size. Here I will use the test size is 0.2. This means 20% of the data will be used for test set and 80% of data will use for training set. Here random state attribute I will keep it as 0. This means that if we put any specific random state, then the values which we will get on every execution, that will remain the same. In short, we will not get the random values every time we run the model. Okay, so let's execute this cell. Done. Here we have split this data into training set as well as test set. Let's see how is the data looks like. Print xtrain xtest ytrain and ytest. You can see here 3, 4, 5. This up to this is the xtrain, this one is xtest, this is ytrain, and this is the ytest values. Okay. Okay friends, are you ready for the final tool, that is a feature scaling, which allow to put all the features on the same scale? And let me quickly remind why we need to do this. That is because for some of the machine learning models, in order to avoid some features to be dominated. Well, I am going to show you how to implement this through code. Here in x variable, you can see that in the first three columns, the values are 1, 0, 0, 0, 0, 1. So these values are too less compared to the values in this column and the salary column. So we have to apply the scaling on those two columns. One is age and second is salary. So let's do this from sklearn dot preprocessing. I will be importing standard scalar. Okay, then I'm creating the object of class standard scalar, and I will not pass any values to the attribute. I will just keep it as default. Now I am going to apply the feed transfer method on xtrain. Keep in mind that we only have to apply the feature scaling only on the age column and salary column. So for that I have to do slicing in this way. So xtrain 3 to 5. So it means it will take column number 3, means index 3 and index 4, excluding the fifth index. In this case, you can see that this is 0, 1, 2, this is third, fourth, and 5 will be excluded. So third and fourth will be taken into account. So I'm going to apply feed transfer method sc.scx dot fit transform. Okay, everything is looking fine. So let's execute this code cell. Okay, now let's see how this looks. Xtrain. Okay, so here you can see that those values are on the same scale, like 0, 1, 0, 0.26. It is comparable. 0.12, it is comparable. The same for X test. In this case, we only need to apply the transform method because we already have fitted it on the Xtrain. So the model can learn on the basis of Xtrain set, and according to that it will transform the X test. So scx.transform X test 3 to 5. Let's execute this code cell and print this. Okay, so here we got the two rows. You can see here that those values are minus 1.45, minus 0.9. These are comparable, means.
Welcome back. I hope you really enjoyed this video. If you really like this video, then please hit the thumbs up, and if you are new to this video, then don't forget to subscribe to my channel and press the bell icon to stay tuned with the coming updates. Thank you so much.